Hi, it's Pavel with a Visual Basic exercise from the book Introduction to Programming with Visual Basic, Chapter 6, Programming Challenge 7 or Programming Project 7, whatever they call it. We are going to determine if the word is a palindrome. A palindrome is a word that reads the same forward and backwards. For example, racecar reads racecar forward or racecar backwards. The same Madam, I'm Adam, or was it a cat I saw? Those are all palindromes because they read the same. Now we will write a program that allows user to input a word or phrase and then determines if it is a palindrome. The program should use a boolean-valued function named IsPalindrome that returns value true or false, depending whether the word or phrase is a palindrome. Now we need to remove all spaces and punctuation before analyzing the word. In other words, like the question mark or a comma or this apostrophe or whatever, these will be all removed, and the same with spaces. Basically, we will have just a string of characters with no spaces or punctuation. Okay, so I already made a form. Here we will enter the phrase. Here in this text box it will simply say yes or no depending whether it is a palindrome or not, and determine if palindrome button. When clicked, it will determine whether the word or the phrase the user entered is a palindrome. Okay, so the first thing I'm going to do, I'm going to find a word or define the word, which is basically the word.text. That's the input from the user. Now we need to replace all characters other than A, B, C, D, all the way to Z. So here, this one is the ASCII table that will simply tell you the number or the decimal number of the character. For example, capital A is 65. It's right here. B is 66. And Z is 90. In other words, characters with the values of 65 to 90 are the capital A to capital Z. Over here you have 97 is lowercase a and 122 is lowercase z. But we don't have to worry about this because we can convert the whole string into, let's say, uppercase and do a comparison whether the character we are checking is between 65 or 90. If it is, then it's an alphabetical A through Z. If it's not, then it's a different kind of a character. Okay, so to do that, we simply do a little loop. So we will do for I as integer, and it equals to integer equals to 0 to the word dot length. That's so we will check all the characters in the string, and within it we will check if the integer value of the ASCII character, the ASC function or a method that is built into the Visual Basic, of the word dot to upper, again we are converting them to uppercase, and now we are getting the actual character, which would be the substring, and the substring we are looking for is the index I. That's the current character within the loop, for each iteration that we are checking. And the length, how many characters are we checking? Just one. So I is the character and 1 is the length. In other words, we are only checking that one character. Now if this is less than 65, because remember 65 was the uppercase A, I probably messed up some parentheses. Yeah, there's no need for parentheses over there. Word to upper. So if this is less than 65, or I will do an OR statement. or it is greater than 90. 90 was the uppercase Z. So if it's less than 65, which is less than uppercase A, or greater than 90, which is the uppercase Z, then it's not a letter that we are looking for. We are simply going to ignore that or remove it. So, but I still have the I'm missing and if. Oh well. And if. How about now? Okay, so now what do we do when we encounter a character that is not A, B, C, or all the way to Z, which is, let's say, a question mark? Well, we could remove it, but if we remove it, what's going to happen is our length of the word is going to shorten. If I do something like a word equals word dot remove and a character that I want to remove, then the length will shorten and it will come over here, and what's going to happen is that it will suddenly get out of bounds, because now we are this length will not be the same as the beginning length before we remove the character. So instead of removing character, we will simply replace it with something, and the best way to replace it would be the string. I mean the space. So we will replace the character of the substring of the length 1. In other words, the current character that we are checking, and it's not and it's, let's say, question mark, we will replace it with, and let's replace it with a space. So now instead of question mark there will be a space, but it's still a character, so the length will be the same. So it will not mess up the counter or the bounds, and it will not get out of bounds. And that's really all how to not remove but replace all the characters we don't want. We will replace with the space. Now at the end, I'm replacing it with a space because at the end we can do simply something like this, word.remove, and we will remove all the spaces with nothing. Alright, so this will remove all spaces. So at this point, our word will contain only letters A through Z and no spaces and no other characters at all. Okay, so now I can let me create the function. That's gonna be a public function. I call it IsPalindrome, and it will accept the word as string, and it will return a boolean. It will return true or false depending whether it is or not a palindrome. So I will do a variable called reversed word as string. I'll initialize it to just empty. And now what I'm going to do is to move the word in a new string and then make a comparison. So what I mean by that, we will go to another loop, and again it will equal the length, the word dot length, but this time we'll go from the end. So we will go from the end to the beginning. So it will be the word dot length to 1, except this time it's gonna be step -1. We'll go backwards. We'll go from the end of the string to the beginning of the string. And over here we will do the reversed word. We will simply append the word dot substring of I -1 and the length of 1. Again, we are going backwards. So I want the last character, which is going, and then the one before that, and before that all the way to the first one. So at the end, a reverse word will hold the reverse string of this word, and this word already has no special characters. So now we can simply compare them. If a reversed word dot to upper equals word dot to upper, then we have a palindrome. We can return true, else we will return false. So now I come back over to my click event, and I'll simply do if IsPalindrome, that's the function, and I'll pass the word. Again, that's the word with no special characters in it anymore. So if this function returns true, then our text output.text will equal yes. It is a palindrome, of course, and else it will not be a palindrome. So it's no. All right, so let's see if that runs. So let's start with the racecar. Racecar. Oh, and it's gonna. The index length must refer to a location within the string. What is the index length now? It's 7. So if I do a race car, the index 7 would be at 0, 1, 2, 3, 4, 5, 6. So okay, we get out of bounds because, all right, here it is. The word length is the maximum, the length of the word. We need to do one less. The one less is because the length of the substring we are looking for, of the last character, would get us out of bounds. Because again, let's say the maximum length or the characters in the word race car, it was 6, right? I mean 7, but it starts with 0, so that's why we need the -1. So if I do it again, and it's still not doing it right. Okay, let me see. A word is not valid. Conversion string. Oh, because I do the remove. I'm sorry. See, I said I was showing you that we cannot use remove, so I wrote remove, but it's supposed to be replaced. We are replacing the strings with a null or with empty. We're not removing them. So one more time, race car. Ooh, it is. What if I add a space there? It still is. What if I add like a question mark and quotations and exclamation point? And it still says it is. But if I add another letter, let's say E, it should say no. And it still says yes. For some reason. So that's not good. Alright, let me try it one more time and see what the heck is going on here. Alright, let me try that again. So if I go, what was it, race? I'll do some space, question mark, whatever, another space, array, and car, and that should be a palindrome. But if I add another letter, it says, oh, I add in the letter, it still actually reads the same, R-A-C-E, R-A-C-E. So it's still the palindrome because I added E, but if I add, let's say, R, now it says no, because now it does not read the same from the front and the back. Ah, jeez. Alright, so, well, let's say P, alright, it's still no. But if I do E, then it says yes. If I delete E, it still will read the same. If I delete this one, it still will read the same. But if I delete this C, R-A-C, it still would be the same. See, this is the thing that it actually are palindromes, but again, now it's not. Okay, so let's do a phrase. What was it? Was it a cat that I saw? Is that the phrase? Was it a cat I saw? Not that I saw. Okay, was it a cat I saw? And it says, yeah, it is palindrome. If I put again bunch of you know, other characters, it will still recognize it. If I do another letter, let's say P, now it's not reading the same, so it's not a palindrome. And finally, let me just paste this one. So if I add this, it should be a palindrome. If I do I am, now it's not. Alright, so hey, that's a working program, I think. So again, let me recap what we did. We came over here, we captured the text that the user entered into a text box. We loop through each character, -1, because it's a 0 base, and we are comparing the substring of I of the length 1. But what we are doing, we are not comparing we are getting the ASCII value between 65 and 90, because those are the ASCII value of the uppercase A, B, C, all the way through Z. That's why we are having the return value of this is an integer. It's a number, and again, from 65 to 90 is the correct one. That's what we are looking for. So if that's why we're converting into integer. The ASCII character over here returns the value or the number of the character, and to upper obviously converts it to upper character. So again, between the 65 and 90 are uppercase A through Z. And if it's one of these words, in this case, if it's less than 65 or greater than 90, that is not A through Z, and then that's why we remove that character or replace it with a space. We are not removing it from the string because that would mess up our length over here. Our loop would not be the same anymore. The word would be shorter than the length over here. I mean the length would cut off. Basically, what would happen is that the word.length would be after we remove a character would be one less than what was originally looped for, and that could cause the out of bounds. That's why we are only replacing the character with a space. But at the end, we will remove all the spaces, and all that is left are A through Z, capital A through capital Z, and that's our word. Now we will go and create the palindrome function that accepts that word already stripped out of all characters that we don't want, and we will loop through that, except we are looping backwards. We are looping from the end and assigning each of those characters to our string reversed word. So at the end, reversed word will be obviously a reversed of the original word that we passed into this function as an argument. So if our word matches the reverse word, we have a palindrome. If not, we don't. So hopefully that was helpful. Not much confusing, and yeah, try to debug it maybe, to see how the values are being returned, especially with these ASCII characters, and yeah, play with it a little, and I'll see you next time. Take care.